I'm Natasha Duarte, the director of the Composting Association of Vermont and chair of the Food Cycle Coalition. And we're joined by Eric, Sarah, and Kate here, who are going to be talking about some of their microplastics research that they've been doing at the University of Vermont. Dr. Eric Roy is an assistant professor in the Rubenstein School of Environment and Natural Resources, as well as the Department of Civil and Environmental Engineering. He's also a fellow in the Gund Institute for Environment. He leads the UVM Nutrient Cycling and Ecological Design Lab and conducts research on several topics related to applied biogeochemistry and nutrient stewardship, including organics recycling. We're joined by two of his students. Sarah Hobson is a master's student in the Rubenstein School of Environment and Natural Resources at the University of Vermont. Her research focuses on microplastics and nutrient cycling in organic wastes and agricultural soils. We're also joined by Katie Porterfield, who's a PhD student and a Gund Barrett Fellow in the Department of Civil and Environmental Engineering at UVM. And her research focuses on resource recovery and reuse from organic waste streams. And so Eric, with that, I'm not sure who's going first, but I'm going to pass it over to you and your team.
Okay, so thank you so much for having us and for inviting us, Natasha. Really pleased to be here. I know we've spoken to probably a few of you out in the audience about this issue, but we're glad to connect with more of you. So just a little introduction to our lab, so you know a little bit more about us if we haven't met yet. So the lab's called the Nutrient Cycling and Ecological Design Lab. So I lead the lab, and you know, as Natasha mentioned in the intro, I do a lot of different research, including topics such as composting, anaerobic digestion, nutrient cycling and management, soil science, and the environmental impacts of food waste. And so we have a pretty sizable team these days of around 7 graduate students, including Sarah and Kate, who I'm really lucky to work with, plus a research technician, and several UVM undergrads assist us with our research. And so we organize our work around the broad theme of nutrient stewardship, and that includes nutrient use efficiency in food systems, resource recovery and reuse, and nature-based solutions and green infrastructure. So one of our key objectives in the lab, which is especially pertinent to this group, is we aim to perform research that can help inform and guide organics recycling to effectively recycle nutrients and support soil health. And, you know, as we've been doing this research for the past several years, you know, the topic of contamination comes up, and including microplastics contamination. And we see this as a challenge that can impede successful organics or nutrient recycling. And it seems likely, based on conversations I've had recently, that we could see some policy on microplastics in Vermont at some time in the near future. And so we think it's really important to try to get out front and better understand this topic. And that's what we're aiming to do right now with several research projects. And so, you know, our key goal, we're working with a variety of stakeholders. Like I said, I've probably chatted with a few of you already. And if I haven't chatted with you yet, I'm probably hoping to sometime soon beyond just this webinar. But, you know, at the university, I see our role as trying to fill key information gaps through research to evaluate strategies for recycling challenging food waste streams. And so those are streams where we might be more likely to see contamination that presents challenges to effectively creating soil amendments or other forms of nutrient recycling. And so we have funding right now from Casella Waste Systems and the UVM Gund Institute for the Environment. And with Casella, as you'll hear about in a few minutes, we've received funding from them to support sustainable materials management research at the university. And we've used that funding to better understand their depackaging system in Williston. And so I guess I'll present this one, Kate, and then I'll turn it over to you. But, you know, part of our research is motivated by the fact that there is a sizable portion of the food waste stream that I like to call challenging, because it involves packaging in many cases. So the 2018 Vermont Waste Characterization Study found that an estimated 38% of food waste in Vermont is packaged. So these are streams that under the universal recycling law need a solution, as well as the unpackaged streams. And some of those unpackaged streams might also have problematic features in some cases, such as contamination in post-consumer contexts. So we're really interested in trying to find solutions for these types of materials, in addition to, you know, the more classic pure food waste streams that, you know, are also being managed. And Kate, you can take over from here.
Good. Thanks, Eric. And thanks, Natasha, for the introduction. Again, my name is Kate Porterfield, and I'm going to talk briefly about my research to date and then our future, my future research plans in this area. So currently, for the past year, I've been working, looking at the depackaging system. And I have a picture up here on the slide of a different depackaging system. This one's been installed at the South San Francisco Scavenger Company. And I just wanted to put up a visual so that we can understand what this instrument, this machine is trying to accomplish. So you start with a packaged or contaminated food waste stream, and a depackaging system can separate that stream into an organic stream. In this case, it's a pretty solid mash, and then a reject contaminant stream. So my research questions in this area, first off, is mechanically depackaged food waste a suitable substrate for anaerobic digestion? So to answer this question, I'm using a variety of methods. I'm doing biochemical methane potential tests in our lab using an instrument called an AMPS-2. It stands for Automated Methane Potential Test System. And that just tells us how valuable those food waste streams are going to be to produce biogas using anaerobic digestion. And I'm looking at packaged ice cream and post-consumer food scraps. And the reason we chose those two food waste streams is they kind of represent opposite ends of the spectrum in terms of how heterogeneous and, you know, packaged or mixed a food waste stream might be. So what we found so far, we're still working on this, but our initial data suggests that yes, mechanically depackaged food waste, at least the ones that we looked at, are suitable substrates for anaerobic digestion. So our biochemical methane potential results are in line with other results that have been reported in the literature for similar types of food waste. And my second research question gets to more of the challenge of recycling these types of food waste streams, and it's how contaminated is depackaged food waste with microplastics. So the methods for this question have been a little bit trickier to develop because measuring microplastics in organic materials is a pretty new area. And so we've been having to adapt methods that have been used to measure like really organic rich ocean sediments. And that's been challenging, but I think we've made a lot of good progress. And just to quickly go back and talk about what microplastics are, plastics really can be divided into these different bins. Macroplastics are larger than 10 millimeters, mesoplastics are between 5 and 10 millimeters, microplastics are less than 5 millimeters, and then the really small ones, nanoplastics, are less than 1 micron. And the microplastics that we're focused on are ones that are 0.5 millimeters and above for now. And that's because that's the lower detection limit for the instrument that we have at UVM to really positively identify anything as a microplastic. And another thing about microplastics that's important to remember as we talk about them in the context of food waste is that there are a lot of different pathways for plastics to enter the soil environment. We've been doing a literature review, and Sarah's been looking into different ways that plastics can enter soils. And some of the ones that have come up a lot for her are atmospheric deposition, water from irrigation, waste from litter from roads nearby, and tires, soil amendments, of course, compost or biosolids or other fertilizers, and then other materials that are used intentionally on farms like black plastic mulching. Okay, so the problem we're trying to address is that land application of food waste residuals could introduce microplastics into the environment. So like I mentioned, we're doing this literature review, and we were able to identify 11 peer-reviewed papers providing original data on microplastics and organic residuals. And in those papers, we found the values typically ranged. So this is aggregated across all the papers, those 11 papers. We found 12 to 2,800 particles, microplastic particles per dry kilogram of compost, 75 to 895 particles per dry kilogram of digestate, and 40 to 1,400 particles per dry kilogram of food waste. So I think the important part to notice there is that those are really wide ranges. They're highly variable, and also the ranges are overlapping between those three categories. And this variability is likely driven by multiple factors. Of course, the feedstock and the processes involved in creating that organic residual are going to play a role. If you're starting with a less contaminated food waste stream, you could have fewer microplastics in the compost or digestate. But there are also important methodological things that could be playing a role in this variability. So a big one is the size fractions you consider. So we had that slide showing the different bins you can categorize plastics in. And a really important thing is that some studies are looking at microplastics greater than 1 millimeter. Some are looking at microplastics greater than 0.5 millimeter. Some are going all the way down to 30 microns. So there's kind of a really wide range in like what sizes people are even looking at. And if you're comparing numbers between them, the size fractions you're looking at is going to influence how many plastics you're counting. If you're only looking at things that are greater than 2 millimeters, you're not going to count as many as if you're considering smaller fractions too. And our preliminary data suggests that the microplastics counts that I'm getting for these depackaged food wastes fall within the typical ranges that were found in compost digestates and food wastes around the world. And none of these 11 peer-reviewed papers were from the US. They were all from abroad. Okay, so this is a picture of me under the microscope counting microplastics on a sieve. So the general methods that I'm using right now to count microplastics in the food waste, the first step is to isolate them. So I have to remove all the organic matter, whether that's food waste, in the future, it could be, it might be compost. We're also looking at digestate. Once the organic matter is removed, which is a really challenging step that we're trying out multiple different methods to do that right now to figure out what the best way is. Then you have to positively ID things as microplastics. So you can see on the sieve here, there's a bunch of stuff left over after the isolation step. Not all of that is plastic. A lot of it is just recalcitrant organic matter that wasn't degraded. So I have to look under the microscope and I use a dichotomous key to pick out potential microplastics. So a dichotomous key is just a decision tree. It's basically the first decision is there visible cellular structure? If yes, then I exclude that one. If no, go to the next decision tree. So everything that I pull off as a potential microplastic gets cataloged and it's sorted by its size. So I'm putting them into 3 different size bins and then 3 different shape bins, film, fiber, fragment. And then with a subset of these potential microplastics, we're going to use something called an FTIR scope. And what that does is we shoot a ray of infrared light at our particle that we think is a plastic, and it gives us a vibration frequency. And then we can match that vibration frequency to a library of known vibration frequencies and figure out what type of plastic we're finding. Okay, so as I mentioned, there are a couple challenges that we've come across with the isolation step in particular. Incomplete organic matter removal is a problem. So in this picture on the right, you can see a lot of residual material in the sieve. And under the microscope, it's kind of like looking for needles in a haystack because you have to wade through a lot of organic material to find the plastic. So that's challenging. And then on the left, another issue is illustrated. which is some of these chemical methods that are used to isolate microplastics conventionally can get to really high temperatures. And a lot of the plastics that are relevant to food waste are these really thin film plastics that are used in packaging. So they're sensitive to melting at higher temperatures like that. So it seems to me like some of them are melting using that method, which is why we're investigating other methods as well. And another challenge that we're working on right now is that this method is giving us microplastics as a count, a number of microplastics per mass or weight of material. But a lot of the regulatory stuff that's going on around microplastics and compost and digestate, both in the United States and abroad, typically in almost every case that I've been able to find, the regulatory limit is a % per weight. And we don't currently have a reliable way of converting between count per weight to % per weight. And so the methods that are being developed in the literature don't really match the sort of regulatory structure that's emerging. So that's something that needs to be reconciled in the future. And this is a picture of some of the microplastics that I've found under the microscope. There's a scale bar, so you can see that these are, some of these are, one of them's under 1 millimeter, some of them are around 2 millimeters, some of them are bigger. And these panel A and B in particular, and C, these types of small film fragments, anecdotally, I would say, are the most common things that I'm finding.
Okay, I would just add that the reason these look cleaner is because this is a different method. This is a biological method we're using where we're essentially employing the microbes to help clean up the plastics for us. And by doing that, we're left with a result that is much easier to work with, will be much easier to weigh eventually. So that's
not melted.
And yeah, it's not melted. Exactly.
Key. Thank you, Eric. All right.
All right, so I'm Sarah. I'm a master's student working in Eric's lab with Kate. And Kate has kind of been covering microplastic contamination in anaerobic digestate. But obviously anaerobic digestate isn't the only organic waste, and compost is another pretty large waste stream. So I'm interested in whether there are also microplastics in compost. There are many different types of compost. It's not all just food waste derives. And when we're creating compost, we're also adding in a bunch of bulking agents and stuff. So I'm interested in kind of the end product compost. So I hope to research microplastic contamination in this finished compost, specifically in the state of Vermont, maybe looking at around 20 different composts, ranging from ones that are from cleaner streams, such as manure, and more contaminated streams, such as potentially food waste. And we really need partners to do this in industry that are producing this compost. And I hope to kind of count microplastics and go through with this research question with two main methods that Kate kind of covered earlier. First, you have to extract the microplastics, and this can be done through kind of digesting away or oxidizing the organic matter, usually done with like hydrogen peroxide, and then doing some sort of density separation. This is done in like a salt-based solution, and then using microscope, stereo microscopy, as Kate showed earlier, to identify potential microplastics before using an instrument called an FTIR to identify them. And that's just an instrument that shoots an array at the particle that kind of emits that spectrum back to this device that can interpret it and compare it to a library of known material spectrums to confirm whether that material is indeed some sort of plastic or not. And this will provide context for future research. We'll know kind of what ranges we're working at when we're thinking about contaminated compost. So when we're doing future work, make sure we're working at relevant concentrations. And yeah, so what's the point of all this work, right? Well, as Kate mentioned earlier, these organic residuals, whether they're anaerobic digestate or compost or other forms, they eventually usually end up on agricultural soils as soil amendments and in our food systems and our environment. So Kate and I conducted a literature review looking at not only abundance of microplastics in the environment and in these waste streams, but also potential physical effects and biological effects. So some of the physical effects or different ways of microplastics being in the environment, they tend to concentrate at the surface. That makes sense. They tend to have lower density than soil particles. And also if you're looking at the means of application, whether it's through atmospheric deposition, irrigation, or application of organic amendments such as compost or digestates, that's always to the surface. So they tend to be at the surface. They might transport other chemicals, as do most all soil particles. They might absorb different chemicals, they might release different chemicals. Soil chemicals might be more or less bioavailable with the presence of microplastics. And then across studies, the effects of microplastics on the physical environment really varied with the environment. So what was the soil texture that microplastics were looked at within? What type of microplastics were looked at? What concentration? There are so many variables that it's hard to concretely say what the physical effects of microplastics will be in the soil column, but some potential ones included increasing soil aeration, water repellence, porosity. If you're thinking about these maybe less dense particles being introduced to soil, there could be risk for things like erosion. And then we also found like decreased bulk density, maybe aggregate size and structure or water holding capacity. If you think about the material of plastics, they kind of repel water. They don't really absorb that. So water might run off. It might not be absorbed in the soil. Yeah, but when considering these, always note that it's very contextual. And biological effects of microplastics, again, are also very contextual and depend on many factors. When we're looking at the biological effects, there are many different scales ranging from organism levels to entire ecosystem levels, and most of the studies focus on just an organism for simplicity's sake. Again, there are many different possible effects. A lot of studies found changes in root growth. Some found decreased root growth. Some actually found increased root growth of crops as a stress response. Some found lower biomass growth or lower seed germination, possibly changes in soil microbial community diversity or functioning. Others found, increases in transport of different chemicals in the soil, or maybe some oxidative stress, phytochemical concentrations. Those are just measures of biochemical responses that plants or animals might have to introduction of different chemicals. And then maybe inflammation that was found in earthworms. Again, these studies, they're very dose dependent as well. These are ecotoxicity studies I was looking at, and those generally tested plastics at very, very high concentrations that aren't relevant today in the environment. So should all be taken with a grain of salt. But yeah, so it's also important to note that physical and biological factors are very much interconnected. So if the water holding capacity of soil changes or the soil moisture content changes, that's a physical factor that will have biological effects on plants. if the aggregate stability changes, there are also biological impacts. So how do we separate what are the impacts directly from microplastics and what are the impacts, the biological impacts that are just a result of physical changes? And then again, like the effects really vary with the environment. And we need more information to really understand how microplastics in the environment might impact conditions in Vermont soils. Another thing I'm interested in, given the general dearth of research on microplastics and their effects in the environment, is their effects on biogeochemical cycling. And I want to kind of focus on nitrogen and carbon cycling and how microplastics might impact those. And I'll be working with Dr. Debnir and Matt Scarborough, as well as Eric Roy, in this research. So two of the main indicators we look at for these are organic matter decomposition and nitrogen mineralization. And I'll be looking at this through incubation experiments. So I'll take some agricultural soil, apply a given amount of microplastics to it that will be a relevant concentration from the abundance study in compost. And I'll kind of look at the gas emissions and see whether carbon cycling, nitrogen cycling of these are impacted through looking at these two main processes of organic matter decomposition and nitrogen mineralization. And now I'll pass it back to Kate.
Cool, thanks, Sarah. So those are kind of all the things that are going on in terms of lab projects right now. So we're trying to characterize microplastics in food waste and food waste residuals at the lab scale. But then as a next step, we want to take that data and try and scale it up to the state level and use it to figure out, you know, what's the best thing to do with these really contaminated and like Eric said, challenging food waste streams. So to do that, we're going to conduct a life cycle assessment. What a life cycle assessment does is it basically compares two processes and across a number of categories, both beneficial impacts in terms of fertilizer offsets and energy offsets, but also in terms of detrimental impacts like eutrophication, greenhouse gas potential. So it gives each process a score for each of those categories. And then you can kind of start to compare the two on more even playing field. And that's when it gets a little bit more subjective, because you have to figure out, okay, which of these impacts do we want to focus on the most? So at the moment, we're in the very, very beginning phases of this project. We're in what's called the goal and scope definition phase. So we're meeting with stakeholders in the food waste management area. We've met with many people who are on this call right now, and we have more meetings planned and scheduled. And what we're doing right now is just trying to gather information, see, you know, what's out there, what people think are reasonable scenarios to include in this study, and also to figure out what are the particular waste streams that are most challenging and that we should really be focusing on. Okay, so the specific research questions for this are, what is the best end use scenario for a contaminated food waste stream in terms of known environmental impacts? That's where the LCA comes in. And then we want to add this extra component that hasn't like really been done before in life cycle analysis, because there's so little information out there. But we're hoping to use some of the data that we're generating from my project and from Sarah's upcoming project to incorporate this question of what is the flow of microplastics to agricultural soils under each management scenario. So we'll have a management scenario and we'll have impact scores on all of these different known environmental impacts, but then we also want to add under that management scenario, what's the flow of microplastics to soils? And then the final question is kind of going to be synthesizing those two and figuring out what's the optimal end use based on known environmental benefits and burdens, including microplastics flow. Okay, so I'm just going to quickly walk through what an LCA actually looks like, because it's very kind of theoretical sounding, and this visualization is just aimed at helping people understand what's actually going on behind the scenes. It's a lot of spreadsheets, but I tried to make it more visual, and this is just an example. This isn't necessarily the actual scenarios that we'll include, but it will probably be similar to this. So the first one is a landfilling scenario. So each of these boxes is a process at which point you would calculate impacts, so inputs and outputs from managing a ton of food waste. What's the fuel consumption from transport, from compaction? What's the greenhouse gas emissions when that's landfilled, and so on to the end of treating the leachate. Okay, so an alternative scenario might be anaerobically digesting that same amount of food waste. So we're going to include some of the same processes, but there's also a lot of new ones. There's transporting the residuals from depackaging to the landfill. There's biogas production, which can be captured, and that can count as an offset in the model. And then a kind of sub scenario from this would be to include so still anaerobic digestion, but maybe instead of land applying the solids, you landfill them. So you're still extracting some value from them in the form of energy as biogas, but then if the residual poses more of a danger if you land apply it, then it's worth maybe landfilling it would be a better option. These are all just hypothetical scenarios. And then another one we would certainly want to include is a composting scenario. So that's going to include emissions and resource consumption from turning and screening the compost, as well as transport. And I think if you keep going, Eric, there's one more component of this. Okay, so yeah, at each of these different points, you'd be accounting for different resource use consumption. So diesel, electricity, water, wood chips are just a few examples of the many that would go into these spreadsheets. All right, over to you, Eric.
Yeah, all right. Well, thank you very much, Sarah and Kate. And so I'm just going to kind of summarize some key takeaways and some, I think, challenges we have to deal with, both researchers and practitioners, when it comes to this topic. The first is this fact that there's many sources of plastics to the environment. So there's been some attention growing on organics recycling as a source of potential microplastics contamination. And as we continue to generate new information to better understand that piece of the puzzle, I think we always need to try to put that into context as well in terms of other potential sources to the environment. So we have a good idea of what the most effective strategies overall are to help reduce plastic flows to the environment. And so, based on all of the literature we've seen so far, and some of our early results, food waste and food waste derived soil amendments may contribute microplastics to the environment. As Kate mentioned, there hasn't been a lot of work in the United States. Data are relatively scarce overall. A lot of the data we've seen is coming from Europe, mostly. And so there's just a need for more information so we can have a better sense of what's out there, what the variability is, and how different processing or handling strategies might impact the flow of microplastics. And then the environmental effects one is also tricky. I mean, there's been several studies on this. As Sarah mentioned, one of the key limitations of some of those studies is the dosing they use. If you use, a dosing rate that's orders of magnitude more than any of the concentrations that have been measured in soils, yes, maybe we see a response, but it's hard to know what to do with that information. How well does it apply to an agricultural soil in Vermont? That's not straightforward. And so, part of our work by linking the quantification of microplastics abundance in different materials to our experimental work in soils, we're hoping to conduct experiments that are more useful in terms of these are realistic quantities of microplastics that could be introduced to Vermont soils. And do we see an effect or not? And then to continue to build information of that type. And I think all of this is leading to some big questions in a regulatory sense, such as how much is too much? How much is too much? I think a target of 0 would be extremely challenging to hit in terms of microplastics introduction to the soil. But like other contaminants, we'll probably need to go through some sort of process to establish thresholds that we consider below that to be acceptable and above it to be unacceptable. And right now, we just don't have the information to make that type of system. And I know the state of Vermont is looking into this as well, and we're doing our research. So hopefully over time, as more information becomes available, we can get a better sense of what is the best approach to trying to do what I think any of us would agree needs to be done, which is try to limit the introduction of plastics to the environment, but to do so in a way that makes sense given all of our other goals, such as organics recycling. And so, like I said, we're looking at both abundance, and eventually we'll be looking more into the effects. I know a lot of this is preliminary. This topic is generating so much interest. We're having trouble getting some of the work done because we're talking to so many people about it. So we'll be, having a lot more results coming in the new year, and I look forward to sharing those with you in the future. And so we just wanted to pose some kind of open-ended questions. And I think there's a few questions in the chat for us already, but some things we're wondering is, for those of you operating composting systems, what has been your experience with plastic contamination and food waste feedstocks? We're a lab that's very active in the field. We visited a lot of facilities. We see this stuff with our own eyes, and we talk to a lot of people. So we've heard some stories, and we'd like to hear more. Any research questions you have? As we're designing some of this, the life cycle assessment work that Kate was talking about, for example, is right now in the design phase. We haven't really kicked that off yet. Sarah's soils work is also in the design phase. So we really welcome your input and anything we can do to improve those studies. And then, I come back to this fact that, unfortunately, we're going to have some food waste streams that are more challenging than others. And contamination is something that we'll continue to have to grapple with. And so if you have any ideas, especially that maybe Kate could potentially include in her life cycle assessment, of different ways that, in particular, that type of food waste could be handled in the most environmentally beneficial way, we'd love to hear them. And then, Sarah mentioned this, but, with, more attention on this issue, and I think some of our partners that we've been working with so far are, their goal is to better understand what they have, what's in their material, and then take that information and go from there. And we're hoping, many of you in the composting community feel similarly, and we'd love to partner with you. I've been doing this for a while. I understand that, having contamination measured in a product is a sensitive issue at times, and we're willing to, our goal is not necessarily to, be out trying to find out who has the most microplastics in their compost. We're happy to do things like publish results in a way that does not necessarily ID particular facilities. But I think as a community, we need to know what's out there, what's the variability, and are folks having success with strategies to try to reduce this type of contamination so that we can get better value for the products we're producing and meet those big goals that I think we're all working on together, which is how can we effectively support soil health, how can we effectively recycle nutrients and avoid wasting the valuable resource that is food waste. And so that's all we have for our portion, but we'd love to chat more. And if you want to email me after the chat too, feel free. I'll just leave this up for a few minutes so we can you can write my email address down if you want. But thanks again, Natasha, for the invitation. We really appreciate the opportunity.
Yeah, thanks to all three of you. We had, I'll just sort of summarize, we did have a question about the 11 studies sort of being abroad, and Kate already clarified in the chat that they're mostly from Europe and a few from China. One of the things that I wonder about, and I understand that it was also really limited, but I would imagine that in addition to methodology and differences in methodology and the size plastics measured, of course, if there was any information in that literature about what, if any, separation practices were, like, was it, I know that's sort of perhaps more qualitative, but I do think that we would at least anticipate, commingled loads being collected and processed versus loads that have much more outreach and education around source separation, and maybe do a better job of that. I wonder if that was even noted in the literature, those types of things that might contribute to the range as well.
Yeah, so that's something that I'm trying to tease apart.
Mm-hmm.
I did a really high level summary for this, but in the paper that we're putting together, it's a much more detailed table that gives all of the information that I had about each of those materials. So yeah, so it'll say like the source of the material.
Mm-hmm.
I haven't done any sort of, we haven't done this in any sort of quantitative way, but from what I've seen, it was nothing jumped out at me clearly that like a particular feedstock always had much higher amounts of plastics. So I wasn't just looking at studies that involved food waste for the compost and digestate. I was looking at studies that counted microplastics in any digestate or any compost. So there were like greenhouse composts in there, and like yard waste composts, and their plastics were found in those as well.
Sure. Okay, great. Thank you. Kat, do you want me to read your comments in chat, or do you want to unmute and share? Trying to find you in my list here, but go ahead and unmute if you'd like.
Yeah. Okay, it took me a minute to find the unmute button. Yeah, thank you. And thanks, Kate and Sarah and Eric. This is really interesting work, research, and I'd love to partner with you. We produce compost at school where there's an interesting assortment, as you might have imagined, of plastics that end up in the compost bin despite the students trying to pick it up. So I'd be interested to sort of add that to your mix. This isn't a question, but you asked about my experience or our experiences. And last year, I bought some compost from a established, local greenhouse that I thought I could trust, and they sold me they had it listed as a soil amendment. It was compost, digestate, and normally I would go and check it out, but I didn't. And so it was delivered, and it had at least 5 or 6 visible pieces of small, unidentifiable pieces of plastic and metal, like per shovel. I was totally shocked that it could be sold as a soil amendment. And yeah, it really blew me away. So I buy compost a lot, and I make compost a lot, and I've never seen anything like it. And the color of it was black, which was a pretty clear indication that had been anaerobically processed. So I just wonder, I guess, have you had experiences in the compost that you've looked at where you see that level of contamination?
Well, just to clarify, we have not yet analyzed any compost samples. That's something Sarah's going to bring to the table. We've really only been focused on food waste, kind of upstream, these depackaged food waste streams, and digestate. We have been doing a little work related to digestate, and I had done some in the past as well. Anecdotally, I've worked on composting research, not only in the United States, but abroad in Sri Lanka. And I've had that same experience of seeing visible particles. I think we just really don't have a great handle on what's out there right now. And that's hopefully something we can help, again, fill that gap.
Thanks a lot. Yeah, there's a lot of research to be done. Thank you so much for setting the stage.
Yeah, thanks, Kat. We're going to go to Holden.
Hey, Eric, Sarah, and Kate. This is not our first time connecting here. And of course, just want to reiterate that you have our full support, and we're happy to play a role in, broadening your data set and making your findings as robust as possible. But something that I thought of while Kate was presenting that we hadn't spoken about prior is, have you had any Depack tech companies buying into this? There was a study done in 2019 that showed the variation in essentially microplastic levels based on methodology, whether it be cutting, tearing, ripping, done by, I think it was a Shobani. It was a 2019 study. And it seems to me like these depackaging companies might have some kind of, stake in wanting to create tech that reduces microplastic presence as much as possible. Have they been willing to contribute in any way, shape, or form? Has that been something you've pursued?
Well, yeah, I think that's a gap. You just identified a gap in our outreach, and we've kind of been talking to the folks who are using these machines, but not necessarily the manufacturers. I mean, they do produce some data on contamination rates. It's not clear to me exactly how that data, or how those data are generated. And, I'm not sure if they would capture microplastics, for example. So, we'd be really interested to chat with folks. I think you also, your comment makes me think there's different types of depackaging. And I think when we started doing this research, I talked to a few folks who immediately thought we were talking about shredding, that, things were being ground and shredded, and, clarified, no, that's not how this system works, and that there's a variety of methods that are out there to try to remove the packaging. And I'm not sure right now if we have any information to suggest that one might be better than the other. Of course, if you grind and shred, you're going to have a lot of plastics,
Absolutely,
obviously. But of the machines that are really trying to separate, I don't know if we have any information to help us understand which ones might work better than others.
Yeah, well, if there's any way that we can kind of help you network through that, obviously we have a depackager. We also, work with a network of folks that have depackagers. So I'm sure that there's some networking capabilities there. And in terms of materials that produce more microplastics than others, and policy change, that's something that we talk about quite frequently. Is similar to styrofoam, can we identify certain materials in the plastic waste stream that are major culprits, like black plastics, for example, to-go containers, that type of thing. So love what you're doing. Anyway.
Yeah, thanks, Holden. I mean, that's our goal with the FTIR. Not only do we want to confirm that they are indeed plastic, the things we're picking out, but my hope is that we'll recognize pretty quickly, and I think, Kate, you would probably think we're on track to do this, that there's certain types of plastics that show up way more than others. And that once we know that we can then work upstream, on potential solutions. And I know there's challenges in packaging, moisture barriers are there for a reason. and to my, I was in a conversation about this the other day, and my understanding from what I was being told is that, there's work being done to replace plastic moisture barriers with a material that is better for the environment, but that works in progress, and we don't necessarily have that option at our fingertips yet. But taking the longer view, I hope we do one day, and I hope that the work we're doing can help identify what are the most problematic materials, and which ones should we try to find suitable replacements for in packaging.
Mm-hmm. I'm going to jump in because it's somewhat related. I had a question for Kate, and I think I understood. I just want to be sure that I understood. You said that you were dealing with ice cream and then post-consumer, are those two separate streams? So like one is output from just the ice cream containers and the other is post-consumer stream?
Yeah, so
Okay.
so I'm looking at, and we have a protocol to try and make sure that we're isolating just those streams. So I'm sampling directly from what comes out of the back end of the Depack before any mixing might occur.
Okay.
And I'm sampling just when they're running ice cream alone, and then just when they're running post-consumer food scraps alone.
Great, thank you. Oh, sorry, was someone going to jump in with something else? So part of what I was asking is, I've been told when I have in some conversations with salespeople, to be honest, for depackaging machines, and there are a lot of different ones out there with different add-ons and different. It's pretty complex, and I think one of the misnomers is that like a depackager is a depackager, and they do perform differently. But what I've been told, although again I haven't really seen the data, like where the data is coming from, but I've been told that when depackaging companies say, like 0.05% contamination rates, or give some range, that's based on single stream. So like what I mean by that is as opposed to commingling. So like when you have only the ice cream coming through, or only bags of potato chips, or aluminum cans of, soda or whatever it is, versus this post-consumer or pre-consumer, but commingled, packaged with unpackaged, a variety of different packaging materials involved. And part of the explanation that I was given for that is that, there's all these different ways that you can set and sort of optimize the technology to do as good a job depackaging as possible. But when you have multiple types of packaging, as well as potentially larger volumes of not at all packaged organics mixed in, that it's harder to optimize, and you end up with higher levels of contamination. But what is in their literature is, of course, seems to be the single stream, better looking numbers. So anyway, I just wasn't sure if you guys had come across that, or if you're thinking of that, but Holden's question made me sort of just remember that I think it's really important for, and I really appreciate the detail of the research methodology that you guys shared, because we need to be really clear about what we're talking about and in which scenario, because that it's really easy to sort of cherry pick and match, tell a different narrative depending on which data we're pulling from, if we're not clear about what that data actually represents. So I really appreciate all of the information you've shared.
Yeah, I have also spent a lot of time scouring the internet looking for any sort of data on depackaging machines. This was like a year ago or so when we were just starting this. I haven't done it recently. There might be something out there that I've missed. But what I've seen is similar to what you've said. I did see one study where they did do post-consumer commingled food scraps. And I think that they found that it had the lowest recovery rate of any of the materials that they tested. So they did test it, but yeah, it didn't seem to do quite as, it wasn't a huge difference. It was still like up in the 90s, but it didn't do quite as good a job as when, like, the best thing that I saw, like their highest recovery they reported was for like frozen peas or something like that. Like they said they had like 99.9% recovery or something like that. But again, it's hard with like not peer reviewed data, because I don't know how they came up with that number. Yeah, which is what we're trying to provide some numbers that have a little bit more information behind them.
And Natasha, if we seem a little reticent to post our preliminary data, it's for exactly the reason that you're mentioning, that with such limited information out there, any number that becomes available starts to become a number that could be used and applied in a lot of ways. So we're trying to do our best to get numbers we feel really confident in before we kind of put those out more to the public. Like we said, what we're seeing now is not out of line with what others have found. So But we want to be careful that when we do put out numbers, it's clear what those numbers should be applied to and what they should not be applied to.
Yeah, for sure. Sarah, I see you unmuted. Did you want to
Yeah,
add
I was just
something?
going to reiterate that we don't have like standard methods for counting microplastics. A lot of these industries and private research is, you know, those methods aren't really shared, and it's not very likely that they'll have access to the same instrumentation to measure microplastics. So, or, you know, what size are we even considering for microplastic? You'll get way higher counts if you're considering down to like 20 micrometers. So yeah, just so context dependent.
For sure. Holly, your hand is up.
Thanks. I'm curious about how transportation fits into the life cycle assessment. It seems like there might be some trade-offs depending on the distance of transportation, and it would be really interesting to have that information, especially when we're thinking about how should local communities be making decisions about what's the best use of their food waste is something. Yeah, so definitely curious if that's what you are planning to assess by including all of those steps.
Transportation will definitely be in there. Part of what we have to decide is where we're going to set our system boundaries. So I had a gray dotted line in that example, but we might end up moving it further out to encompass a larger part of the system if that seems, you know, if there's like processes we want to toggle, like transportation. So we will definitely include transportation in it. The goal of a life cycle assessment is to really capture the life cycle impact of a management process, not just the direct impacts that are coming from it that are visible, but if you go both upstream and downstream and look at those cascading effects and add that all up, then and see how they compare then. So yes, we will definitely include transportation.
And just to piggyback on that, Kate, not only will we consider distance, but also vehicle type, you know, these other things that could potentially affect greenhouse gas emissions.
That's great.
Natasha,
thank you.
if you don't mind me, and Ollie, if I can piggyback on what you were saying,
Sure.
we got asked by the legislature in 2020 about transportation, but it was more about looking at transportation versus like landfilling food waste versus it was the specific question was around food waste generated in the Northeast Kingdom, landfilling it versus trucking it as far away as food waste was traveling at that time, which was to Exeter, Maine. It was probably the farthest we had knowledge that food waste was traveling. And even with I think it's like a 6 or 7 hour drive to Exeter, Maine, the alternative for transport was the transport was minuscule in terms of the GHGs. I can share my screen and show that bar chart if folks want. I don't want to divert the conversation without Natasha's blessing, and it may
you
not.
See me shake my head no.
There's data we can share if you want. I think it may even still be in the legislature on that. It's using the EPA's WARM model for that. So it's valuable to think about transportation, but when you start thinking about mitigated methane emissions from landfill disposal is significant. But that doesn't compare necessarily if you were to compost in your backyard versus truck, 3 states over, then you have probably a very different picture. And it might be more of UVM's research that points that out.
And Josh, that makes me think that, one point of a life cycle assessment is to compare different scenarios. Another point is to find the best leverage points to improve performance, right? It's kind of the classic Donella Meadows systems thinking, like what are the things we can tweak that make the most difference? And so that's what we'll hope to produce as well.
Yeah, and what I'd like to offer, Josh, instead of instead of switching gears a little bit to your screen, but I know I've seen that, I'm sure I have it somewhere, but if you can shoot me a quick link to it or as an attachment when I post this recorded webinar, I can include that as a resource on the same page. So folks who haven't seen it will have ready access to it. Awesome, thank you. I just want to share a couple things that have come through chat. One, there was talk about, let's see, the Denmark depackaging technology and some different systems that maybe you guys sort of have found in your literature review, but just so folks are aware, the depackaging has really been, happening in the European context for quite a bit longer, at least than in our little neck of the woods. I'm not sure about the rest of the states, but they've moved to regulation. They've come across, they've been considering microplastics. They've been trying to improve their systems. And in, 2020, 2019, anyway, there is I just put in the chat a recorded webinar that we had as part of a past International Compost Awareness Week content that you all can check out if you're interested in that. And the speakers' names are there, but if you need help finding any contact information, feel free to reach out to me and I'm happy to make that introduction. The other thing I just wanted to bring forward, Fred, I don't know if you want to unmute or if you want me to just go ahead and read your chat comment about the citizen science.
No, it was just a response to Eric saying you needed help. I'm not in the industry. I'm just a gardener, but I'd love to have a little citizen science project. I've been composting yard waste for my neighborhood, 16 households for 2 years now. Seen a variety of things that people discard. And just a little bit of plastic, so it's a pretty pure stream. But I'm just wondering if I know you're busy and you've got so little time and there's so much to do, but is there any kind of theme emerging around citizens participating more with you?
That's something I'd like to think about more. I mean, I think, that we need to think about that more. And it's I mean, the process of doing this work to identify microplastics is really labor intensive and pretty painful. I mean, Kate's smiling now, but it's not necessarily something your average citizen is going to want to sit under the microscope and help out with. But I think where citizens can probably have the most impact is working upstream to try to reduce this problem in the first place, to try to do what they can to clean up the stream so that we're not left with as many microplastics to count. That would be nice. But yeah, and I saw your comment, Fred, about, plastic use on farms. I mean, I think this is going to come up more as we talk about this topic, that again, this is not the only potential source. There's a lot of plastic use on farms for a variety of reasons and for reasons that, are really helpful to farmers in many ways too. So there's trade-offs that need to be navigated. And as we're trying to understand what's in Vermont soils, we'll need to consider, these other sources and think about, are there ways to reduce the introduction of microplastics from those sources as well as organics recycling?
Yeah, I think that hits on sort of a common theme of, the concern is really, whether it's from the composter side, contaminated compost or contaminated soils is the concern, right? And that can come from a lot of different sources. And I also I saw that you're going to share the list of, those 11 publications, and I look forward to that because it's, whether it's from output from a depackager or whether it's a compost site that is having issues with, with contamination, the end product is a contaminated product that we're then using on our agricultural soils. And so I think the focus, I think it's great that you guys are focusing on depackaging. I was really happy to hear that you're also at some point going to hopefully be looking at what kinds of plastic or where that might be coming from, because I think that's part of the key. And I think sort of thinking about, you mentioned some challenges in terms of translating research into policy or regulation in terms of the count per weight versus percent per weight and sort of what that looks like. But I do think that, ultimately we're also going to be collectively wanting to think about the types of packaging and what is, when you talk about the challenging organics to divert, is that not all packaging is the same, right? Is it a big clamshell with a dozen cookies in it? or is it a little tiny thing of cream cheese, individual cream cheese? Is it something that has multiple layers of packaging? I fully understand that you guys aren't getting into that detail. But these are the things I think from a broader picture these are the questions that are going to be coming up, and that we collectively can be thinking about the types of packaging. When is source separation at the point of generation perhaps more appropriate to maintain those clean streams as much as possible versus the completely commingled loads that are just going in regardless of whether there's even packaging there? So some of these questions I think are what's going to come up in terms of the practical applications, but you guys are really helping to start fill in some of the research. We want this based on something, and so that's where we're also running into roadblocks from my perspective. So it's really great what will be coming out of your work. I see a couple other questions have come in. Carolyn asks, I'm just going to read it, Carolyn, for interest of time, but if you'd like to add anything, just let me know. How can we tie industry, the packaging associations more into these discussions and work with them to participate in solutions? So I'm assuming that's just a general open for dialogue question.
I mean, so far, based on our experience, we're talking to like Ben and Jerry's, for example, about, what options are there to, in connection to what we're finding, how can they adapt? How can they improve? And so that's the first step in that direction, but we need to do more. I mean, when I think about this issue, I often think that in some ways, and I count myself in this, we may have underestimated how big of a shift it is to go from a linear economy to a circular economy, and that requires working all the way up the supply chain in many ways, all the way to the packagers. And so I think it's going to be a process of adaptation, but we have to be working across the entire scope of the system, and especially with the packagers. And that's something we plan to try to do more in the future.
Great. Does anyone else want to chime in on that before there was another comment in chat, but I didn't want to cut this conversation. So Anne, I'll just read this again and then feel free to elaborate if you'd like. So Anne says, yes to more public education on food waste reduction, and that and I worry about a composting backlash. If people start to think that it's all full of plastic, they might just give up. It's been hard enough to get Vermonters to comply with the landfill ban on organics. Yeah, I think that's part of it, but I think as well, part of what I hear in the conversations I've been having with different folks around the state is one of the unintended consequences of the introduction of depackaging, whether it was in a partnership with AgriCycle and now Casella as well, is then some folks have reached out and expressed some concerns about the mixed messaging around source separation. So we have to separate at our homes, but we don't have to in grocery stores or in institutions. You have to source separate if you have this hauler, but maybe not that hauler. And I'm not calling that out as good or bad. I'm just highlighting it that it does introduce sort of a wrinkle in the public outreach and education messaging, I think, in terms of how Vermont is utilizing this technology. So I'm just sort of putting that out there as something that I've been a reflection of conversations I've been having. I don't know if anyone else wants to jump on that.
Yeah, I'll just point out that maybe Kate's life cycle assessment kind of plays into here, like creating a potentially like contaminated compost with landfilling it, or if we're able to anaerobically digest it and produce energy from it, even if it is a really contaminated waste stream, it could then be landfilled, but first you could extract a lot of energy from it, or there are many options. But yeah, that certainly is a concern, motivating everyone to compost. And maybe that's part of or just a symbol that we need more education and maybe more funding to support prevention of microplastics into these waste streams. Maybe like thinking about grocery stores, looking at that like 38% of all food waste in Vermont is usually packaged in plastic. Like if you think about the big producers of it, they range from kind of, you know, individual level to grocery stores or even further up the food chain. And maybe grocery stores or other places won't have the money to employ people to unpackage every single product. So I think funding is really crucial as well.
Yeah, I have a question, actually, I think more for Josh Kelly, if that's all right. I just wonder if there's, and it's been a while since I've looked at the report, but is there any distinguishment among that percentage of packaged materials in terms of the type of packaging?
I don't think so. It's been a while since I looked at the waste composition study. Actually, noticed, probably seen it and dug into it most recently as Sarah and Kate, given their slide they showed. No, I don't think the consultant was identifying what packaging it was in per se. Other than, I think Kate showed this in the, or well, whoever put the slide deck together, thank you, it's great. Identified residential and what we call ICI, industrial, commercial, institutional, and they're making a judgment call on that based on what they received from the hauler and the load that came in, where it came from. And sometimes it's hard to parse those out because routes in Vermont are mixed routes. Residents are picked up at the same time a business is picked up. So it tends to.
Yeah. And I thought that was likely the case, but I do think it would be interesting to really start being a little bit more granular in terms of like, is it giant, you know, is it easily depackaged or is it more challenging to depack? And I think that that's likely going to play into future conversations that we have in the state. Yeah, Dan, go ahead.
Yeah, thanks to you guys for presenting and sharing your research, part of your research so far. Look forward to seeing the rest of it. You were soliciting participation from composters. It doesn't look like there's very many of us on the call, so I figured I might as well participate. We're of course happy to partner as you move and expand the scope moving forward. And to answer one of the questions you posed, partially anyway, I think plastic contamination compost is a problem for all composters, and it just depends on the degree, source of material. There are a lot of variables that go into it, but some of the big ones are where it comes from, whether it's residential or industrial or commercial or institutional, and almost as importantly, I think, is who's hauling it and what type of program and importance they put on cleanliness of stream. It's been talked about the commingling being an issue, but even, we see a whole spectrum of, really small haulers for whom that's their only stream is the organics, who do an incredible job of educating their customers and putting a lot of effort to make sure that what is being diverted for composting specifically is super clean. Whereas there's, some of the bigger haulers for whom composting or organics is just one portion of what they do amongst the sea of solid waste management, that it's less important seemingly, and there's less education. And so the plastic content is much general contamination content is much, much higher. So there's a huge variability. And even within our facility, where we've seen so much change over the last year to 2 years, given 1 month to the next, we could see a huge difference in the amount of contaminants coming in versus depending on who's bringing it, where it's coming from, that sort of thing. So I look forward to your expansion of research on that, and I think it's going to be really challenging to get samples that are going to be, hopefully you'll take lots of samples from each location that you're working with over a wide range of time, perhaps, because I think it's going to be hard to come up with one sample that's representative of one facility, much less compost in Vermont as a whole, because there's so much variability. But yeah, glad you're expanding the scope.
Thank you, Dan. And we had planned to reach out to you, so I'm glad you kind of preempted us there. But I completely agree. And getting representative samples is challenging. We do our best to composite, to do repeated sampling, And that's something we'll continue to expand. The issue we face is just the laborious nature of doing the work. And so there's this mixture of wanting to sample as much as we can, but also just being up against reality of, how long it takes to get a sample analyzed right now. Unfortunately, this is, I hope 10 years from now, we have brand new ways to do this that are way simpler, but right now it's a bit old school under the microscope and it's time consuming work. So we'll do our best to get as robust a sampling as we can. And I know the state is talking about a sampling program as well. And we've had communication about how our efforts can be synergistic. I had a conversation yesterday. So hopefully that can lead to results that are more reflective of what's really out there.
Great, thanks. And before we go to Holden, I just want to add that although there aren't a lot of composters on this call today, a number of folks reached out to me about this topic, or I've had some conversations following up the earlier conversation I had with you, Eric and Sarah, with interest in participating. And so offline, I can make some of those introductions and connections. So just because they're not here with us this afternoon, I have like half a dozen composters in various parts of the state who would be interested. So it'll be helpful, perhaps we can do this offline, but for me to just get clear about like how many or what your criteria are for selecting partners, just given what you shared about just the workload of doing the sampling.
Yeah, we're looking for maybe about 20 partners. Okay. And I think right now we're focusing on ones that sell compost.
So not specifically on farm. What about on farm if they're not selling, or if they're selling just a small amount?
We'd have to think about that more. Okay. Yeah.
So more commercial. Good, it's good to know.
And again, there's trade-offs where if the more partners we work with, the less repeated sampling we'll be able to do. So trying to find that right balance is something we have to think more about.
Sure.
Yeah, but definitely more focus on the larger streams as so larger amounts that are produced. But yeah, I hadn't really thought about individual level composting as much, and maybe I'll consider that.
Well, there's some on-farm composters who are taking community food scraps from haulers, but they're not necessarily packaging or selling wholesale the resulted process product. They're actually land applying it for their own fertility, but it's not like me backyard composting or, you know what I mean? So, so if they're taking, if haulers are tipping at their site, maybe that's a criteria you could think about. But anyway, we can talk a little bit more about that offline. Thanks. Holden, go ahead. I can't hear you again. I'm sorry.
Oh, how about now?
Yep, perfect.
Jeez, sorry about that. We've since kind of drifted away from what I originally raised my hand about, but kind of two things. One is, it's interesting, Sarah, you mentioned 38% of all food waste in Vermont is packaged, or food in general. Totally unrelated, that directly correlates with some of our largest partners, what they saw in diversion rates when we install their Depack. So that's some pretty interesting parallels that, totally unrelated from that statistic that I've experienced. But second, I think it was Dan was talking about residential food waste and residential composting programs. And I think it's really important as kind of a community of stakeholders in this realm, that we can find like a unified voice to educate either, we're talking about confusion around who takes packaged food waste, who doesn't, in that increasing contamination elsewhere. And I guess I can just speak to sort of how we brand or market our depacking unit in terms of our interaction with residents, is that it's not a value add by any means. We do not want residents to be using our site for their packaged food waste, because they oftentimes have enough agency to be able to separate. So when we are either marketing that to towns, or let's say have signage at a drop-off site, we won't market it as a packaged food waste drop-off. We try to reserve that for primarily large grocers, like I think Sarah was saying, folks that wouldn't be able to have the amount of person power required to separate to reach their maximum diversion levels. I guess that's just kind of an angle out how we portray it. Is it's not a value add by any means. The packaging that ends up at our site isn't any more valuable than it would be if it went to landfill or recycling, locally or wherever they're disposing of it. And in fact, it's actually more costly from a greenhouse gas and offset level to bring your packaging to us, because we have to haul it twice. We separate it, and then we have to haul it to a facility again. So, and that's something that we try to be very clear about, is this is not something that you should feel virtuous about putting your packaging in our containers, right? And I think helping shape that narrative with everybody in Vermont will be really important, because we don't want to be, utilizing technology on one end, but ruining composting processes as a result, because we're also in those markets too. We're not just in it for the AD. We're also going to be doing composting operations as well, as source separated. So, we have a stake in it. And as folks with the Depack, just kind of let us know how we should be portraying it if we're getting it wrong.
Great, thank you. Eric, how did we do in giving you some of the feedback that you were looking for your team?
This is excellent. Yeah, we
Okay.
really appreciate everyone joining tonight, and thank you for all the feedback and questions and messages in the chat.
Mhm.
I think kind of commenting on some of the conversation that most recently, call me optimistic, but I think if everybody this microplastics thing is going to kind of touch everyone, I think in some ways in the organics recycling industry. And I think if we work together and try to lead through science and lead through understanding and try to generate the information we need to make informed decisions, that it benefits everybody in the long run, is kind of how I'm approaching this.
Great, thank you very much. I think our whole community really appreciates that approach. I'd just like to extend another thanks to Eric, Katie, and Sarah for joining us and sharing all of your information, and to all participants for coming and listening and asking your questions and engaging in this dialogue. The Food Cycle Coalition will be picking back up early in the new year with a new plan of work.
Thanks
Take
for
care,
organizing.
everybody.
Bye,
Thanks,
everyone.
everyone.
Bye-bye.